All right, so I thought it was important to talk about some of the issues I saw with this particular problem. Most of them came with sort of not understanding that t, our function here, our linear transformation, takes things from R2 and maps to R4. So if you wanted to write down what's happening, right, if you want to be really painstaking and use those standard, the whatever they call them, the standard basic vectors or whatever, that you would do something like, okay, I need to show that t of -6, 5, well, I can decompose this into a linear combination of those standard basis vectors. So this is equal to t of 6 times our -6 times our vector 1, 0, plus 5 times our vector 0, 1. And because we have all these lovely things about t preserving things under, if it's a linear transformation, and they told me it's a linear transformation, I can rewrite this all as -6 times whatever the map of 1, 0 is, plus 5 times whatever the heck the map of 0, 1, the image of 0, 1 is, right? The mapping. And so we're getting a result that's an image. Now, what I saw was a lot of students were really good at sort of doing the same elementary, those transformations of those standard basis vectors and using that, but they were doing it where they went, okay, so this is now -6, and what should be times, right, that transformed standard basis vector will be just that first column vector in our standard matrix, plus 5 times. Now, what was happening on a lot of students' work is you wrote 5 times t of, and you still had the t there, but t wouldn't even know what to do with a 4D vector, right, with something out of R4. So we've already done t the moment we use those columns of the matrix, and we're able to just jump straight to here. Some of y'all left it like this as an exercise to the reader, what the heck the actual values of this were. No, thank you. It's not going to take you that much time to just type, this into a calculator or do that basic arithmetic. So please give me that final result. So all of these are the same thing. I did not need you to go through all of those steps. I was completely fine if you jump straight to this without moving through all those beautiful things that the fact that t is a linear transformation gives us. But a handful of you ended up not getting that success you were looking for because you just willy-nilly threw t around after you'd already done that map. The other thing you could have done, we do know that the other way, if we call this our standard matrix A, we could also express the transformation here, that transformation of any xy as A times that, right? So you could have done the matrix multiplication to show us this. So a handful of students did that. 5, 2, 2, 0, -4, -6, 3, -5 times this vector, right, our pre-image, to get out what our image was for -6, 5. That is completely legit as well. So either one of those were fine ways to show that you computed where exactly -6, 5 mapped to in our codomain or our image of that vector.